Okay, so this is the package from the 26. All right, so number 1 is A. Number 2 is C. Okay, yeah, equilibrium constants is depend on the temperature. Remember that one. Number 3 is, let's see, that's the one that we have question about. Let's see what happened. You are giving KEQ for the equation this. So you can see that from this to this, you can see that it is a multiplication of 2. So that means KEQ, remember if you multiply the equation by 2, KEQ is going to be in the exponents up here. So it's going to be square, right? So you're going to square this. So 0.25 square. Okay, so 0.25 square, in case if you don't know this, is 25 times 25. That would be 625. 2 decimal times 2 decimal, so that's going to be 4 decimal. So you get 0.062. So that would be an A. Okay, number 4 is the same idea. You flip this over and then you half it. So that would be an A also. Okay, you flip that number. Okay, so that means 1/794. Okay, so that's gonna be clearly decimal, not gonna be these two. And then you're gonna half of, you're gonna square root that number. Sorry, so if you halved it, you're gonna square root it. So that will be square root of that. Okay, so number 5, you're looking, you have equilibrium constants number, you have the equations. You go from here to here, you can see again you halve this. So that means it's gonna be a square root. Square root of 7.52 times 10 to the negative 2. 10 to the negative 2 square root. Guys, I'm recording a video. 10 to the negative 2 square root. The trouble of trying to do this at home. 10 to the negative 1. Okay. It is true though. Bye. 7.52 square root. Okay, if you do not know how to do square roots. Okay, these guys. If you're gonna do square root of 7.52, what you're gonna do is you're gonna say 7.2. Two of the different one you can think about is 4 square root of 4 versus square root of 9, because 7.5 is in between these two. Square root of 4 is 2, square root of 9 is 3, so it should be between 2 and 3. Time 10 to the negative 1, right? Time 10 to the negative 1 would have been, the answer is between 0.2 to 0.3. Okay, that's your answer. So if you're looking here, the only one that's gonna fit is gonna be B. Okay. E. Oh, anyway, 6 is gonna be E. Okay. What happened? You can already see now. This just flip over, right? So what's gonna happen? That number just gonna flip over. So you are gonna have 1/0.013. Okay, so that is gonna correspond to this. Not gonna be this, not gonna be this. That's too small. That's too small. Okay, because if you were thinking, imagining, you can do it this way. A quick one, 1, 2, 3. So I can do 1, 2, 3. So I want to say 1,000 divided by 13. So you can clearly see that that's gonna to be approximately that, right? Because it can be any of this, because these are really small. All right, number 7, you're just writing KEQ, product over reactant. Remember, coefficient is a power. So for 7, it's going to be A. In this chapter, somehow seem to be saying KEQ is KP, but on the test, I will make sure to say KP versus KC. Okay, so make sure that you can tell them apart. You can't do half and half, so make sure you know that. And make sure never to include solid or liquid in your KEQ or KP or KC equation there. Okay, sorry. 8. we're talking about 8 in 8. Same idea, you're just finding KEQ or equilibrium constants, product over reactants. Again, in this case, they mean KEQ, by means they're talking about KC, equilibrium for the concentration. Okay, so that 8, if you do that in the math department, you're gonna get B. Okay, product over reactant. Okay. All right, number 9, I do need to solve this one out a little bit. Okay. Number 9, you have equilibrium vessels. Let me get a pencil first. Okay, so you have equilibrium constants. So that could be Kc or Kp. Okay, I think, and then they are asking for the partial pressure of the O2. Oops, oopsie, dropping. So what you're gonna do is you're gonna write an equation. Probably in this case, they are giving you an Kp in this case. Okay, so what I'm trying to tell you is I will make a clear distinction on the papers to see Kp. But for most case, if they don't really tell you, like whether it's Kp or Kc, read the question. The question should kind of give you guys clue since they are talking about pressures and stuff. So this is a Kp. Okay. So what's it gonna be? So Kp is equal to product over reactant, Pn2, PO2 divided by PNO. Now notice parenthesis square. Okay, that's what it's gonna do. I'm gonna plug these in. Okay, we do need to do ice table because this is the initial amount that is giving, because it's a closed linear charge with this. That's what it said at equilibrium, what it is. So ice table. Okay, so we're gonna do the ice table. So N2, O2, go to 2 NO. They give you NO at the beginning, 36.1. That's the initial, so these are 0. Okay, change and an equation, equilibrium. Change 0, so it's plus x, that is 2 coefficients, so minus 2x. That's how much it's gonna lose. Okay, x because we don't know exact number. This is x, you're just gonna add this up, so 36.1 minus 2x. You're gonna to plug this into this equation to find Kp. Okay, so let's do that. So that's gonna to be x times x divided by 36.1 minus 2x. The whole thing square is equal to 2.4 times 10 to the 3. Now, notice that this is gonna be x squared. This bottom is also square. Okay, so x squared divided by 36.1 minus 2x squared. I can technically rewrite this as x over 36.1 minus 2x. The whole thing square is going to be equal to this. What does that mean? That means to get rid of square, I can do square root. Okay. So if you do the square root, you're going to get rid of that, and then you're going to get x over 36.1 minus 2x. Again, that I will not ask you a question like this. I will give you guys a free response like question, not the multiple choice, where the number is really weird for you guys to calculate without the calculator. Okay, so I'm gonna quickly do that. In a calculator, I will get 48.989, approximately 50. Move over. Okay, solve for it. You're gonna FOIL it, right? And then you're gonna subtract. Yeah, and then you're gonna get your x answer. Okay, once you get your x, which is I'm gonna quickly do this. 36.1. That's gonna be 1768.5. I'm just gonna round it. To 97.978 x x, don't forget that, plus that to this side, so 98.978x, 176.8.5. Divide both sides by 98.978. X is equal to 17.86. Okay. So again, there is some approximation going on here. So yeah, so your answer for this question is about 17.8, so about 18 ATM or 17 point something ATM. That's what we're looking at. I'm sorry, they show you that. So that's gonna fix for B. Okay. 10 is, hold on, let me move a little bit, is gonna to be, is the system is at equilibrium, what you calculate should be equal to KEQ. Then it's equilibrium. If it less or more is not at the equilibrium yet, they need to go in one direction more favor before it's become equilibrium. Okay. 11. Okay, 11 is one of the questions that a lot of students ask. We're looking for KEQ. Okay. I did mention it before. In the experiment, this is placed. This is the initials. Notice that these are mole, not big M molarity yet, so you have to look for volume. Notice that volume is 1. That's why I can use these as just big M, because divided by 1 is the same number. Okay, so let's do the ice tables and then go from there. Okay, let me get my papers because this place is a little small. Okay, so 11, start with the equation. CO plus H2O, CO2 plus H2. These are already balanced, so we're good. Initial 0.35.40. Notice that my CO is gonna be limiting reagents, look like, right? Because this has mole. Anyway, so these are big M, just so you guys remember. Okay, so at equilibrium, CO is gonna be 0.19. Okay, so that's minus X plus X plus X. Now, you can quickly figure out X because this is equal to 0.19 is equal to 0.35 minus X, right? Now, notice that each one, this is gonna be 0.4 minus X, this is just X, this is just X. Okay, so we can find out X here. So that's mean I'm gonna to subtract that to this side, move that this way, right? Or you can just subtract it this way, like, oops, 0.35 minus, then you are saying you got negative X, this is gonna be negative. Okay, let's see, 20, then it's gonna be 15, so that's gonna be 16, 0.16. Okay, so negative negative become positive. So X is 0.16. So that means I know that this is 0.16. This is 0.16. This is 0.4. 0.4 minus X. So that means, oh, let me pull it up. Sorry, can't see that one. 0. Okay, so what did we get from? I'm showing you this here again. Let me go back a little bit. Okay, this is initial amount. These are 0 to start with. That means these are reducing. So minus X plus X plus X. Coefficients are 1. Okay, that's why the same. Now, if you do this, you're going to get 0.35 minus X. But in the question, it's give you equilibrium concentration is 0.19. So therefore, you can use this to figure out X. Once you figure out X, you go back in and then solve for each one, which I'm doing it right now. So that means 0.4 plus 0.16. That, oh wait, not plus, sorry, minus. Okay, so that means, okay, 0.24, right? Yeah. Okay, so these are all molarity. Okay, so what did the question ask? Go back to look at the question. KEQ. To solve for K, easy. Product over reactants. So 0.16 times 0.16 divided by 0.19. Notice it's 0.19, not the 0.16. Okay, notice this is not 0.4, this is actually 0.24. You're gonna solve for this. Now this one seemed like complicated, but the number wise is okay. You don't really need a calculator for this question, okay, because you can easily still solve it. Why? You can still cancel stuff out. Okay, 6. Okay, so this means I can do with 4. When you have a decimal like this where they both are 2 decimal, you can just ignore it in the sense that you make them multiply with 100, kind of like that. So another way for saying is, let's say we still have that, so this whole thing we can write it as 16 times 16 divided by 19 times 24. Okay, because you can imagine you multiply with 10,000. Okay, so anyway, divided by 4, 6, and then so that's 2, that's a 3. Okay, so that's what we're gonna get. So 16 times 2, 32. You can say approximately 20 times 3, about 60, about half-ish, approximately 0.5. Okay, so we're looking in here for about 0.5 for answers, and we found one. 11 is E. Okay, now 12 is, I think we're okay with that one. I didn't have a question on. That should get you a B. Okay, and then 13. Okay, Le Chatelier principles. Notice that temperature is not changed. What happening? Increasing the pressure. Okay, first of all, increasing pressure, what's gonna happen is gonna do decrease volume. So that means it's gonna favor the side with less. Okay, mole of gas. Okay, I feel like this is not very clear. All right, we're good, I think. All right, so what's gonna happen? So let's see. I think maybe let's do zoom out. It's not. I don't know. There's a lot of flaco in that one. All right. Anyway, so what's gonna happen is if you take a look at here, you're trying to figure out which of the following temperatures not change. Okay, increasing the pressure at the constant temperature not change the concentration. Okay, if you do not want to change pressure, not affect concentration of reactant and product. 1 is do not affect these two, product and reactant. Okay, 1 does not affect. It's do not affect if you have mole of gas on both sides the same, all the same. Okay. Okay, so for the 13, we're looking for E. 2 mole gas, 2 mole gas. Okay. Okay, let's look for 14. Let's try calculating Le Chatelier principle. We're not calculating. Okay, what happened when you add O2 to the thing? If you're adding O2, if you add it, that's a stress. Okay, so what is the system gonna do? System will try to remove. So meaning it's gonna favor the other side. Okay, that's always the case. So therefore, in number 14, the only correct answer is gonna be is C. Because in this case, it's gonna happen. You're gonna make more of this. You're gonna make less of this. That's all it's saying. Okay. 15. What happens if you increase the temperature? You have to look at this. This is the Exo meaning heat is product. So heat is gonna be here. So I'm just gonna say plus heat. What did we do? So same thing as up there. You are adding heat. You're increasing temperature, so you're adding this. So that's the stress. So it's gonna go the other way. So it's gonna make more of this, less of these stuff. Okay. So number 15, correct answer is B. Also, the concentration KEQ or K is gonna decrease because your product is gonna decrease. Your reactant, every single reactant, is gonna increase. So that's why. Notice that only change in temperature will affect the equilibrium, nothing else. Okay? All right, let's talk about 16. In 16 is the same idea of solving. Okay, I think we kind of get it. That would be a C. And then 17 should give you an A. Notice what catalysts do is, well, speed up both sides. Okay, catalysts speed up both forward and reverse reaction. Okay, that's forward. I'm just gonna spell that. It's gonna be reverse. That's it. So therefore, it will not change the equilibrium at all. Okay. Let's see if I can switch that flicker on the side because I'm not sure about you guys. It's a little hard to see. Let's try removing them. Is it better? Not really. That seemed to blinded everything. Maybe just one. That's it. Oh, I think it's better. Okay, it's better. All right, 18. Let's see what 18 is. 18 is, okay, liter, mole. Notice that it's at equilibrium, so you're just basically plugging in product over reactant. Okay, so if you do your math correct, you're gonna get a D. Okay, 19, we're gonna solve it out on papers. And then we'll solve 20 and 21 and 22. All right, 19, if you take a look, okay, again, always be careful with the flash size. I might change it, AP might change it, so make sure you take a look because otherwise don't get using the mole as a molarity. It might not be always the case. Okay, so let's get started. So what's gonna happen? Okay, so ice table again because this is the amount at equilibrium. You have other one. Okay, this is the one that I did it wrong in class on Friday. Okay, so R, I, C, E. Be careful when you have almost the same element here, like N, O, they both has it, just a different letter. Be careful with it. Okay, N2O4 initial 3 times 10 to the negative 2. N2O4 initial 3 times 10 to the negative 2. Okay, at equilibrium, still N2O4, 2.36 times 10 to the negative 2. So that means equilibrium 2.36 times 10 to the negative 2. Let's try to figure out. This is 0. Agree? So that means this is minus x, this is plus x. So therefore this is, I know, maybe I should write a giant dot just to make it not confused. This would be 3 time, I'll just still do time 10 to the negative 2 minus, I'll write x like this. Okay, does it help? Okay, just because I don't want my x and my time get confused, I often write x like this. So you can do your own method. You can do a big giant dot if you want, but I never really like those because those confuse me. So pretty much what happened is this. Now you can see that these both are basically equilibrium concentration. They're equal. You can solve for x. Okay, 3 times 10 to the negative 2 minus x is equal to 2.36 times 10 to the negative 2. Notice x is basically this minus this. Still gonna have 10 to the negative 2 left. You're gonna just do 3 minus 2.36. That's what you're gonna do. Okay, so 10 minus 6, that's gonna be 3. Okay, 9 minus 3, that's gonna be 6.63. Okay? Wait, so sorry, that should be 4. Oopsie. 10 minus 6 is 4. Yeah. There you go. Okay, so that's what you're gonna get. Okay. So once you're done with it, you're gonna just say that that's the x. Right? So that is this. So can we now find Ke cubed? Yes, absolutely. Product over reactant, this is gonna be power. Okay. NO2 square over N2O4. Okay. You can say K, you can say KEQ, either way. Okay. Now notice that you don't need X anymore. You just gonna use this guy. Okay. 2 point. Oh wait. Now that one. The this side. See, be careful which one you're writing. This is down here. Okay. This here is x, which is this, so it should be 0.64 times 10 to the negative 2. Notice that I need to square this. Okay, so that's gonna give you. I'm gonna approximate things right now, so I want to say 0.6 square times 10 to the negative 4. I can say this is about 2 times 10 to the negative 2. That will give you about 10 to the negative 2 there. That will give you about 0.36 over 2 times 10 to the negative 2. 2 is going to be about 0.18. Okay, so that means 0.18 times 10 to the negative 2. That means 1.8 times 10 to the negative, 3. Okay, there you go. So something like that gonna happen. So we're looking for 10 to the negative 3, I'm guessing. Okay. Yeah, in terms of the number, yes, I am really off, because if you look in here, right, number 19, the only one that is close enough is 10 to the negative 3 is C, but you'll notice that the number is about 6.9, so about 7, which is possible because I round about 0.3 here, right? And then up here around about 0.04 square. So yeah, I round a lot. So yeah, you will have an off number, but at least the powers whiles is about the same. You should be able to figure out. Yeah, stuff like that. Okay. Let's do 20. Okay, 20 is another one of the crazy question, hard question. Okay. For the 20, again, I will not ask this question on the test. Wait, actually, no, I will ask this question. 20, you can do the 20 without it. 20, they give you K. Yes, 20 has a sum error. This should say 10 to the 8. And also should not say KEQ. It should just say KP, not SB, KP. Okay, because KEQ, also be careful on the test of writing KEQ. KEQ could be either KC or KP, right? P's with the pressure, C's with the constant, concentration. Sometimes a little bit hard to tell. So I don't generally like using KEQ a lot, but then a lot of time you will see KEQ for equilibrium constant. So how do you know which one is which one? So when you have a question like this, unless they tell you that this was specifically KC, you will assume it's a KP because your equation is all gas, and they are talking about in ATM. Okay, we're gonna assume that they're not gonna make you convert between C and P. Okay, that's what we're gonna assume. Got it? Okay, so based on this, I'm gonna write it down. They give you here, you don't need I's because they give you equilibrium mixture. So you already know the E. You don't need I and C, right? Because you already know the E. Just plugging in and solve. So KEQ, or I can just say KP, because I want this. Let's just say this is KP. 1.49 times 10 to the 8. Okay. Why don't just make a mark on this so that I can fix this question later. Because when I typed it, I will forget it. But anyway, I'll fix this one later. for the next time kind of thing. But then you will see how easy it is to solve, because that's going to be product over reactant. So let's see. 3 gas. Oh, they didn't know that third gas. That's fine. That's my product. So I can just say X. The other one is 8.60 times 10 to the negative 4. The same stuff. So you can do square of that. Send it over to this side. Okay, so that would be a 1.49 times, I'm gonna do all the 10 to the power together. Okay, 8.60 times 8.60 times 10 to the negative 4 times 10 to the negative 4. That whole thing go away because negative 4 is positive 8. I mean negative 8, and this is positive 8, so go away. So you're just gonna solve this. Okay, you can do 8 times 9 or 9 times 9, either one you're approximating. So that means about 81, less than that. And then time about 2-ish or 1.5-ish. So obviously over 100. Okay, this is greater than 100, we know. So you can say 1 times 10 to the 2 in the scientific notation. We're looking for 10 to the 2 because we don't know if it's 100, but I know it's around there. Okay, so then if you're looking at the answer, correct answer is E. Okay, the rest doesn't make any sense. All right, let's look at 21 and 22. Those two are a little bit hard because we're back to the ICE table. Okay, again, I'm going to talk about a couple of things. Is if they don't really tell you, okay, you can assume things. So on this kind of test, I will tell you what they are looking for. So I will give you that this is KP instead of KEQ, because otherwise, without unit, it's really hard to understand difference between KP versus KC. But this time, let's just say we're dealing with KP. Okay, so this is an error in the question. Let's go with that. Okay, so what does it start with? At equilibrium, it is 0.99. Okay, so what is a partial pressure of PCl3? Okay, let's try to find out. Okay, P is equal to P of PCl5 divided by P of PCl3 times P of Cl2. I know it's a lot of P, but the first P here is the pressure, the second P here is the phosphorus. Okay, anyway, so I do have a Kp, which is 2.01 equal to, I do have a PCl, sort of, I don't have it yet, I have a mole. Guess what? PV equal to nRT. Okay, so that's what I'm going to do. So P for this guy is going to be 0.99 times, my R is 0.0826 times T here said 500 divided by V is 1 liter. Okay, you're going to solve for that. Okay, calculator. And then that's going to go to here. These two are the same because coefficients is the same, power is the same, whatever it is. We can say that this is X and then this is X to make it easier. Okay, so 0.99 times 0.082, I would just say 26. I'm not quite sure is that number. Let me see, 0.08206. 206. Okay. 0.08206, and then time 500, so we're gonna get 40.619. Okay, x squared equal to 40.619 divided by 2.01. Okay, what are you gonna do next? You're gonna to root it. Okay, if you square root it, you're gonna get about x is equal to 4.495, approximately 4.5. So 21 answer is a C. Right? I mean, yeah. Okay, and then you're gonna do 22. Same idea. Okay, you just gonna do solved it out. Again, it's depend on this other I'm putting on, because these two numbers really close. I'm not quite sure if it B or C, depending on what I'm writing. I don't have my sheet with me, but I think that's the number. Okay, but anyway, let's go through 20. Wait, sorry, I'm already solved 21. So let's look at 22. Okay, so 21 solve. Okay, 22. Same idea actually. If you look, KP time this, and then they give you the charge word. Okay, and one extra, right? Because this time, guess what? Allowed to incorporate. That means this is initials. Whoops. So allow me to go. But that's okay. PCl3 plus Cl2 go to PCl5. What did they give us? They give us PCl5. That's I. Ce 0 plus x minus x. Again, coefficients are all 1. EXX 0.300 minus x. Let's do k. K is equal to, right, 2.01, which is equal to these. 0.300 minus x divided by x squared. Gotta solve this and then plug it in. Okay, let's see. Shoot, I make an error. Like, so be careful. Again, you can't combine these two together because this is my mole and this is my pressure, so not that one. Okay, so I gotta need a pressure for that one because I have a mole. Okay, how do you do a pressure? PV equal to nRT. So we're gonna do that. PV equal to nRT. So P is equal to nRT over V. So N is 0.3, R is 0.08206, T here is 500. Divided by volume here is 1. 0.3 times 500, oopsie, times 0.08206. We're gonna get 12.3. Okay, that's what we're gonna put in here. Does it make sense? Now this is the pressure. Okay. Oh wait, 0.9. Okay. So now I can go back to K. 2.01. This is gonna be x squared. 12.309 minus x. So for this side, 2.01 x squared is equal to 12.309 minus x. Send it over. You gotta do quadratic. Negative b plus or minus square root of b squared minus 4ac over 2a. This is a, this here is b, this here is c. Okay, that's what it is. Okay, so that would be negative 1 plus or minus square root 1 squared minus 4 times 2.01 times negative 12.309 divided by 2 times 2.01. Okay, 4.02, negative 1. I'll choose a plus so that I get the plus answer. Square root of, let's try to find this. 4 times 2.01 times 12.309, so that's gonna be 99.9, so about 100, so you should get 10 minus 1, but yes. Okay, So that divided by 4.02, you will get about 2.238. Okay, that's your X. What do we do now? Partial pressure of PCl5. Okay, PCl5 is right here, so you're just gonna plug it back in. 12.309 minus 2.238. Yeah, 10.071. Okay, sorry, math kind of disappeared down here. That's what it's gonna get. So if we were matching, the answer is A. Right. Okay, I kind of need to go back to 21 just to make the mistake. Sorry, not that. Okay, because I thought 21 they give you an equilibrium one, but they didn't. If you look at it again, it's charged it and allowed to equilibrate. So this is the initials. Okay. Yes. But it's the same idea as how you would do it. So if you're going back there, we're gonna do the same thing. Ice table. So 21 ice table. PCl3 go to Cl2 PCl5. This is gonna to be PCl5 0.9900 initial see equilibrium plus x minus x 0.99 minus x plus x plus x. Okay, the only exception, this here is a molarity. Okay, can't put it in there. What you're gonna do is you're gonna try to change it to, if you're gonna do in a molarity, you're gonna need KC. We don't have a KC. We have a KP. Okay, so what we're gonna do, again, I will let you know on the test about whether it's here is KP or KC. Okay, depend on that, the calculation will be very different. So yes, so what we're gonna do now is I'm gonna somehow do this so that this is all in pressure so that I can have a KP. So to do in a pressure, we're gonna do 0.99 mole. Where does that come from? It's come from right here, 0.99 mole of PCl5. That's initials. And then we're gonna use it with PV equal to nRT to find a P. Okay, so PV equal to nRT. So P is equal to nRT over V, N is 0.99, R is 0.08206, T is 500 divided by 1. How do I know? It's right here. All right, 0.99 times 0.08206 times 500. 40.6197. Okay, this is ATM. Now I can replace that. So if we were to rewrite that last part of PCl3 plus Cl2 go to PCl5, I can replace 0.99 with this so that I get the pressure one. So it's gonna be X, and then this is 40.6197 minus X. Okay, 40.6 I will use. Okay. Now, what we're gonna do is we have Kp, so let's solve for that. 2.01, which is equal to product over reactant, 40.6 minus X times X squared, 2.01 X squared equal to 40.6 minus X squared plus X minus 40.6 equal to 0. Square root again, plus or minus, okay? Negative B plus or minus square root of B squared minus 4AC divided by 2A. Okay, obviously I'm going to pick plus because this is my negative. Seem about the same question, but okay. 1 minus 4 times 2.01 times. Okay, oopsie, not that one. Square root the answer. Okay, so 18.1 about minus 1 divided by 4.02. That's gonna be x is equal to 4.25. Okay, so that's x. So that means it's either PCO3 or CL2 is 4.25, and that's ATM. Okay, PCO3. So that would be B. Okay, got it. So ice tables do make a lot of difference.